You love talking about GPS technology, so let's talk about this diamond magnetometer.
Yeah.
It represents a breakthrough in quantum sensing technology that is transforming how we measure and map magnetic fields. At the heart of this revolution lies the nitrogen vacancy center in diamond crystals, which enables these quantum uh, magnetometers to detect the magnetic fields with extraordinary precision. These advanced sensors provide unprecedented magnetic field mapping accuracy, operating at a sensitivity level that were previously impossible to achieve in compact devices. So, what does this mean for the industry, John, and why do we care?
Yeah. So this is cool because they're using synthetic diamonds that could replace GPS in any situation, but especially situations where satellite signals are blocked or jammed. So it's a tiny diamond chip that can sense the Earth's invisible magnetic field patterns and use them like a fingerprint to determine your exact location without needing any satellites at all. Because GPS, for those of you that don't know, need satellites in order to determine location. So how it works, just dive into it real quickly. The Earth has a magnetic field. Surprise? Maybe not. It's like a giant invisible magnet. Think of it like that. So the field varies slightly from place to place due to underground minerals, rock formations, a bunch of different things. And these variations create essentially unique magnetic fingerprints for different locations. So the diamond magnetometer, it acts like an ultra-sensitive magnet compass that can detect these tiny variations and match them to magnetic maps to pinpoint your location. So why does this matter, right? So this is great because you don't need supercooling like what we had covered in other satellite-less GPS potential solutions. So it could enable navigation underwater, deep canyons, inside buildings, underground, where GPS signals are jammed. So there's a lot of use cases for this. Now, the breakthrough lies in using, and I don't know much about this, but it's a nitrogen vacancy or NV centers in a synthetic diamond. So these are atomic scale defects where a carbon atom is replaced by a nitrogen atom with an adjacent vacant space in the diamond's crystal lattice. This creates a quantum system that's extraordinarily sensitive to magnetic fields. So really cool. Do you think, Craig, that this is a technology that's closer to commercialization than other GPS technologies that we've covered?
This definitely seems, even though with the name Diamond in there, it seems a more inexpensive and easier to deploy than a lot of the other. Like if I remember correctly, and you can correct me wrong, we talked about the quantum GPS, and I thought it had several lasers pointed at a centimeter size device to determine micro sensitivity movements. If that what we were talking about?
Yeah. Yeah.
Yeah, that seems like just on the surface, we don't have costing. That seems way more expensive than what's going on here.
Yes, for sure. This seems way more feasible. I think they have to super cool the other thing too. So apparently doesn't have to be super cooled, I don't think. But it does use green laser light and emit red light that varies in intensity based on the surrounding magnetic field strength. So this one still does use lasers, but it doesn't seem as complex to develop further.
Yeah, and manufacturing scales from 2-inch to 4-inch wafers to boost industrial adoption of the diamond sensors. So I think quantum magnetometers allow for reduced operational calls via fewer recalibrations and maintenance needs. You talked about this before, and I don't remember the number, and maybe you do. How much is lost in shipping because of bad GPS? Are we losing stuff every year?
Well, I think was it in the billions or hundreds of millions?
It was definitely in the billions, and that's why, like, when we think like the average consumer is like, okay, great, I like a little bit better GPS when I'm driving downtown Toronto or in heavy buildings because bounce off Billy doesn't quite know where I am. But other than that, it's generally good enough. Why do we need this? And we sit back and say, okay, we need this because of all the things you mentioned, right? You mentioned the technical high temperature environments, high pressure conditions, corrosive atmospheres, advanced geological surveillance, underground studies, like all the things, which is great. And being able to do this more accurately at a significantly reduced cost is really going to boost the industry. So I do believe this is going to be adopted faster than the other ones.
I think so. Yeah.
Biomedical applications benefit from non-invasive, high-resolution and nerve activity monitoring, as an example. So, we start looking at some of this, the applications for the magnetometer in this is outside of GPS as well. It's amazing. I love what the accuracy, the magnetic navigation may soon rival GPS thanks to real-time magnetic field mapping systems. So you'll be able to put this potentially in your phones and whatnot, and not necessarily have to talk to satellites anymore.
My question is, if this relies on the Earth's magnetic field, right? What happens if the magnetic field reverses? Will they have to just recalibrate or redevelop a whole new chip?
I assume this is how it's going to work. It's all going to be just like you have GPS maps, or used to.
Yeah.
Back in the day when everything wasn't connected, you'd have to download the maps for where you were going and whatnot. But now it just gets them automatically. That it would be an eye in the sky that just downloads your updates when you get in that are relevant to your area, and then overall to the world, depending where you are.
Yeah.
So, when it shifts, it'll shift, but they do shift. But I think the whole point is that there are systems and networks out there. As soon as you deploy these systems, millions of them across the world that can communicate with other system, now you're tracking it. You can sense the micro shifts. You can update the database. It's just like how Waze and now Google, I guess, tracks drivers in your car, how fast they're going, where the slowdowns are, where they're not, and changes your route. It's the same thing for this type of thing, where as you sense the differences in your phones or whatever your sensors out there, it'll update those maps accordingly.
Yeah, absolutely.
So I think this is really cool. I love new technology around GPS and knowing where we are. And it has, diamond magnetometers offer several advantages: extended operation without satellite dependency, reliable performance in challenging environments, autonomous navigation in GPS denied scenarios, and consistent accuracy regardless of location. So, single chip design eliminates multiple components, native vector measurements capability, simple calibration procedures, and low maintenance requirements. Solid state construction with no moving parts, resistant to shock and vibration, long operation lifetime, and minimal drift over time. So all of those things lead to, we're going to see something soon, and it looks like something we should be implementing.
Yeah, the military, there's a whole bunch of different militaries developing it. DARPA, U.S. Air Force, MIT, NIST, there's a whole bunch. Honeywell, so they're all working on something similar. So something will get to market sooner rather than later.
And it sounds like something they could use on Mars for sure. Elon Musk and his team when they go. All right, let us know what you think about this. We'd love to hear back from you. So what do you got going on, John?
Oh, I don't even know when this is coming out. So September?
No, we're only a couple of weeks ahead now, so it'll probably come out late July. So if this isn't coming before July 22nd, we have a July 22nd Flowgrammer meetup featuring Superbase. Going to be great. I think you're presenting at that. I'm presenting at that. We got a couple other people lined up. The swag from Superbase has been sent, so it's on its way. Awesome. I don't know what that is, but we'll see when it arrives. And in August, we'll be doing another Flowgrammer event. I haven't picked the date and whatnot yet. And we'll be back at Start of Investor Drinks in September. But what do you got going on? I saw something where you're presenting.
Oh, yeah. This will be passed. It's life. Yeah. I will have presented on government funding. And if you have any questions on government funding, reach out to me on LinkedIn, John Irwin.
Fantastic. For everything else, check out flowgrammer.ca for business and AI automation. We'd love to hear from you. If you're looking to automate stuff in your business, go over to flowgrammer.ca. Find out our events in Toronto where we do our local meetup events. We're going to start some online stuff, some inner circle stuff coming soon. But check out everything going on over there for business automation. Book a free call if you like. And for everything else, for our startup community, go check out torontostarts.com. Thanks, everyone, for watching and listening.
Thanks, everyone.